Greetings Year 11/12 students and welcome to exercise 3C. Today we're going to be sketching some weird looking curves and let's get into it. Now we've got a menu before we get into the actual process. The menu states before we even start anything we've got to get our ingredients ready. Let's do some preparation before we actually start cooking. The preparation is that if there are separate fractions we combine them to get a common denominator, and then we're going to factorize the top and the bottom as far as we possibly can. That's our preparation. That's getting the ingredients ready. Once the ingredients are ready, then we've got four main things we have to look at. First of all, we find the domain. Secondly, we look to see whether the function's odd or even or neither. Thirdly, we find any intercepts and draw a sign diagram or table. Fourthly, we find any vertical and horizontal asymptotes, and then we go about sketching it. So let's try our first example. Sketch y equals 3x squared over x squared take 4. Well, first of all we have to prepare it, and the way we prepare it is we factorize it. So we know that the top can't be factorized any further, but the bottom is a difference of 2 squares. So we could write it as x take 2, x plus 2. And so there you have it. Now, that's our preparation done. That's step 0, preparing it. Now, step 1. Step 1 was to find the domain. Now we look at this question, and if we look at the question and we're trying to find the domain is all x values except for x cannot equal 2 and it cannot equal minus 2. Because if x was equal to 2 or minus 2, we'd have zeros in the bottom of our fraction, and you can't have 0 on the bottom of a fraction. Step 1 finished. Step 2, let's check to see if there's any symmetry. Now, to test if it's an odd function or an even function, we replace all of the x values with minus x. So it'll become 3 minus x squared on minus x in brackets squared, take 4, which becomes 3. Oh, hang on, I've made a little mistake there. Let's actually fix that up. That's better. I don't want the squared inside the bracket. It's just minus x inside the bracket. So that becomes 3x squared over x squared take 4, which is the same as the original equation up here if f of minus x equals f of x. We know that it is an even function. Let's go to step 3. Step 3 says find the intercepts first. So if I'm going to find any x-intercepts and y-intercepts, to find the x-intercept, I'm going to let y equal 0 in the original question. So it becomes 0 equals 3x squared over x take 2, x plus 2. Let's multiply the denominator across to the other side. When we do that, you get 0 equals 3x squared, because 0 times x take 2 and x plus 2 gives 0. Divide both sides by 3 and the square root of 0, you get x equals 0. To find the y-intercept, we let x equal 0. If we go to the original question and we let x be replaced with 0, we're going to get 0 on the top of the fraction. 0 over anything is 0, so you'll get y equals 0. Now we're going to draw a sign diagram. Sign diagram or a table. Now, what values do we need to put on our table? Well, this is where we need to be a little bit careful here. What we want to do is we want to put special values on our table. Now the special values are going to be, let's have a look. I'm going to put them around, let's go x, y, and the sign. So I'm going to put them around the most extreme left asymptote, which is -2. I'm going to put them around my x-intercept, which is 0, and my extreme most right asymptote, which is +2. Now I need to pick values around that. So I'm going to go to the left of -2 is -3, between -2 and 0 is -1, 1, 2, and 3. Now, I know that there's some asymptotes, so there are no answers where there's asymptotes. There's asymptotes at 2 and -2. At the x-intercept, when x is 0, y is 0, which doesn't have a sign because it's 0. Let's start plugging in numbers. When I plug in -3 into the original question there or there, I'll end up with 27/5, which is positive. When I plug in -1, I'll end up with -1, which is negative. I shouldn't have put a dash there. I'll put a 0 to say that it's not positive or negative for under the 0. When I put in 1, I get an answer of -1, which is negative. When I put in 3, I get an answer of 27/5, which is positive. So there's my sign diagram completed. Let's draw or go to step 4, our final step, the vertical asymptotes. Now, how to find the vertical asymptote? You set the denominator to 0. So I've got vertical asymptotes at plus and -2. And plus or -2 are not solutions from the numerator, so they stand as asymptotes. Now I have to do a little bit of analysis. I say as x approaches -2 from the left, what happens to y? As x approaches -2 from the right, what happens to y? Well, if I put in a value into the original question here, and I'm just going to do this, you can test it yourself. If I put in a value there that's a little bit less than -2, that's something like -2.001, my final answer is a large positive number, and I get that. Now, I can see this if I come to my sign diagram. If I go to -2, to the left of -2, I've got a positive, which means that's going to be a positive number, and it's large. If I want to use my sign diagram here, I could put in a number like -1.999, or I could go to -2, but I'm on the right of it. I'm going to get a negative number, so it'll approach -infinity. As x approaches 2 from the left, and as x approaches 2 from the right, what's happening to y? Let's have a look. As x approaches 2, to the left of 2, you get negative. To the right of 2, you get positive. So to the left of 2, negative. To the right of 2, positive. So we can actually cheat using our sign diagram to get those answers quickly. Now the horizontal asymptote. Now, to find the horizontal asymptote, I'm going to go to the original statement here and divide everything by x squared. 3x squared over x squared gives 3. X squared over x squared gives 1. 4 over x squared gives nothing, because if x squared is large, 4 over x squared is approaching 0, which means my horizontal asymptote is approaching the number 3. And as x approaches minus infinity, what's y approaching? Well, if we go back and plug in minus a really, really large number into the question, so come back here and put 999 into the question there or there, when you plug it in, you're going to get an answer that's very, very close to 3, but it's just a tiny bit bigger than 3. So y approaches 3 from above. We know that's going to approach 3 because 3 is the horizontal asymptote. As x approaches plus infinity, put in a large positive number, you also approach a positive value, just a little bit bigger than 3. Now it's time to sketch our graph. So let's sketch our graph. We put in our asymptotes. There's an asymptote at -2 and at +2. So vertical asymptote at x equals -2. Vertical asymptote at x equals 2. Horizontal asymptote at y equals 3. So there's our asymptotes. We know that the graph touches the x-axis and the y-axis at 0 because our x-intercept and our y-intercept is at 0. So I've put on my asymptotes, my intercepts. I know that it's symmetrical, it's even. Even means it reflects perfectly across the x-axis, across the y-axis, sorry. Let's see what happens. When I'm approaching my x equals 2 asymptote, to the left of it, y is big. To the right of it, y is very big and negative, which means I'm going to get this. Really big to the left, big and negative on the right. As x approaches minus infinity, we're approaching the line y equals 3 from above. That's what the plus means. When x approaches the next asymptote, which is 2, from the left, we're approaching minus infinity. Okay, so the left, we're approaching minus infinity, which means we're going to go like that. When we approach the asymptote x equals 2, from the right, y approaches plus infinity, so y is large and positive. And as x approaches infinity, y approaches 3 from above. That's what the 3 means. And there is our sketch. Let's try the next one. Righto, question number 2. With question number 2, we'll notice first up that there are actually 2 fractions. Well, step 1, preparing everything, we actually had to merge them and get a combined fraction. So we're going to say that this becomes, get a common denominator, so it'll become x take 6 plus x plus 2 over x plus 2 x take 6. So what I did was I multiplied the first fraction, top and bottom, by x take 6, the second fraction, top and bottom, by x plus 2, and then I've got a common denominator, so I put that together. That will actually equal x plus x is 2x, take 4 over x plus 2, x take 6, and completing the factorising, I get 2 bracket x take 2 over x plus 2, x take 6. That's the preparation work done. Righto, step 1, let's find the domain. Looking at the original question, I can see what the domain is. X can't be minus 2, x can't be 6. If I look at my tidied up version, x can't be minus 2, x can't be 6, so it can be everything else. So the domain is x cannot be minus 2 and x cannot be 6. So that's actually going to be my vertical asymptotes through there. Let's check the symmetry. So let's try f of minus x into this bit here. If I do that, actually, I could do it there, or I could do it on the original. It wouldn't really matter, but let's put it into this one here. It's going to become 2 minus x minus 2 over minus x plus 2 on minus x minus 6. Now, if I take out common factors of minuses and that's not going to equal, that does not equal f of x, and it certainly doesn't equal minus f of x, which means this is neither odd nor even. It could be really weird. Let's go to number 3 and find the intercepts first. So if I go to find the intercepts, to find the x-intercept, I'm going to let y equal 0. So I'm going to go to this here, let y equal 0, and remember it's y equals all of this. So I get 0 equals 2 x take 2 over x plus 2 x take 6. Multiply the denominator across to the other side. When you times it to 0, it just becomes 0, which means x equals 2 as my x-intercept. To find the y-intercept, I let x equal 0. And if I go to the original question and let x equal 0, I can do it here or here. If I let x equal 0, I'll end up with negative 4 on the top and negative 12 on the bottom, negative 4 over negative 12, which becomes, well, let's write y equals negative 4 over negative 12, so y equals 1/3. Let's draw a sign diagram. Now, with the sign diagram, we've got to make sure we get the right numbers, so x, y, and our sign. What numbers are we interested in? Righto. The first number I'm interested in is minus 2. I'm also interested in 6. I'm also interested in an x-intercept of 2. So, minus 2 is the first number I'm interested in because it's a comes from there. It's actually going to be my vertical asymptote. Next one I'm interested in is going to be plus 2. I'm interested in plus 6, and I'm interested in numbers either side of all of those. So I've got a number either side of this domain restriction, a number either side of this domain restriction, a number either side of my x-intercept, and they're in order from left to right according to my number line. I do know, because x can't equal minus 2, that there won't be any y values for those ones. X can't equal 6, won't be any of those. And when x is 2, I get y equals 0, which means the sign is 0 for that one because that's an intercept. Now let's pick some numbers to work around. A number to the left of minus 2, a number between minus 2 and 2, a number between 2 and 6, and a number to the right of 6. Righto, if I put negative 3 into the question, I can put it in here or I can put it in here. But if you put negative 3, substitute it into the question, you end up with negative 10 over 9, which is negative. Substitute 0 into the question, you end up with 1 over 3, which is positive. Substitute 3 into the question, you end up with minus 2 over 15, which is negative. Substitute 7 into the question and you'll cancel down to 10 on 27, which is positive. So that's our sign diagram sorted. Let's now do our vertical asymptote. set the denominator equal to 0. We can see the vertical asymptotes are at -2 and +6, and you don't get -2 or +6 as answers in the top. So here's my vertical asymptote, and as x approaches -2 from the left, and as x approaches -2 from the right, what happens? Well, let's look at our table. To the left of -2, I'm going to be negative. To the right of -2, I'm going to be positive. So y approaches negative infinity, y approaches positive infinity. As x approaches 6 to the left, and as x approaches 6 on its right, what happens to y? Let's look at the table. There's 6. To the left of 6, it's negative. To the right of 6, it's positive. So to the left of 6, it approaches negative infinity. To the right, positive infinity. So that saves having to plug values in because I was able to use my sign diagram. Now we're going to find the horizontal asymptotes. Now let's look up here and consider that's y equals 2x take 4 on x squared take 6 plus 2, which is take 4x take 12. We're going to divide every term by x squared because that's what the highest power of x in the denominator is. And that will leave me with y equals 2x over x squared. X on the bottom is bigger, so that's going to approach 0. 4 over x squared, that's going to approach 0. X squared over x squared will be 1 minus 4x over x squared minus 12 over x squared, which approaches 0. So my horizontal asymptote is going to be 0. As x approaches infinity, what's happening? So plug a really, really big number into our question, like 9999, there or there, it doesn't really matter. And when you do it, you're going to get an answer that is just a tiny bit bigger than 0. When you plug in minus infinity, you're going to get an answer that's very close to 0, and it's going to be negative. Now, how did I know that? Well, I know it's going to approach the asymptote, and minus infinity is way out to the left, so it's going to be minus, and that is why it's minus, and out to the right it's going to be plus, and that's why to the right it's plus. Now it's time to draw a graph. Let's try our graph. We need to put on our asymptotes. Now we have an asymptote at -2 and an asymptote at 6. So there's our two asymptotes. That are the vertical ones. We have a horizontal asymptote. That is y equals 0. We now need to start trying to get some of our graph on. Now we do know that it touches the x-axis at 2. Well, that's a bit weird, even though there's an x touches the x-axis at 2. And it touches the y-axis at 1/3. Now it goes through an asymptote, and that's okay. It's actually allowed to go through an asymptote. It's at the extremes where it tends not to do it. Now, what happens right over on the left-hand edge of our graph? That's out at minus infinity. When x is approaching minus infinity, a really large negative number, y is approaching 0 from underneath. That's what the minus says. What's happening as we approach this vertical asymptote? Well, when we approach our vertical asymptote at -2, on the left of it, we're negative. On the right of it, we're positive. When we approach -2 from the left, we're approaching minus infinity. When we approach -2 from the right, we're approaching plus infinity, which means I'm going to get this. What's happening as we approach our asymptote of 6? As we approach our asymptote of 6 from the left, we're going to minus infinity, and to the right of 6, we're going to plus infinity. So to the left we're going to minus infinity. To the right of our asymptote we're coming from plus infinity. I'm guessing it does this, I'll check it in a second. As I go out to x approaches plus infinity, y approaches 0 from above, which is correct. There is our graph. Wow, what a mess. Now it's time for you to try doing some. Enjoy the experience after all. You learn through a few bits of frustration, trial and error, and be happy. Bye for now.